So just to look at this tough question we discussed yesterday, it's asking for the potential difference across that voltmeter when it's at P and at Q. So actually, probably the best way to start, let's start thinking about P to start with. Probably easiest actually if we redraw this circuit. So when the slide is at P, that's over down this bottom bit, it's effectively a circuit like this. This is 3 volts and that's 3 volts. Now let's think about our loops. Probably the easiest one to do here is to go around this way. So within that loop, the sum of the EMFs equals the sum of the potential differences or the potential drops. So 3 volts here, the only other thing in the circuit is the voltmeter, so the difference across that has to be 3 volts. That's where all the potential has to be dropped because the EMF in that loop is 3, so there must be 3 volts across here. Or if you think about it in terms of that sort of track model I was talking about, or as we go round, if we go through here, we gain 3 volts of potential, 3 volts, 3 volts. So on this side of the voltmeter it's 3, and we know that this side of the battery is 0 volts. So either side of that voltmeter is going to be 0 this side, 3 this side, so the difference is 3. So we know it's C or D. Now you could guess at this stage, but let's have a look at why it is one of those two. So let's now redraw it when it is connected at Q. So when it's connected at Q, that's there, we effectively have this circuit like this. Now, we've got to think about what loops we can do. Now that resistor is a bit annoying because we don't have much information about it. So I'm going to try and avoid it initially, but we may have to. Let's start by going around this way. Again, you can draw a loop anywhere, as long as it's a closed loop. The sum of the EMFs within that loop equals the sum of the potential differences or drops. So I go around this, you can see that the sum of the EMFs, those batteries are in the right direction, they're like this together, plus, minus, plus, minus. So it's going to be 3 plus 3, the sum of the EMFs. And that's going to equal 6, which must be the potential drop. And again, the only thing in this loop is this voltmeter, so there must be 6 volts across that. If we want to use that analogy again of sort of starting here with a truck and going through this battery, picking up 3 volts, keep going around, we've got 3, we go through this one, pick up another 3, so we've got 6 volts or 6 joules per coulomb, or 6 green bags per truck if we're using that model. And we know this side was 0 because that's where we started. So this side of the battery, of the voltmeter is 6, this side is 0, so the potential difference has got to be 6. So our answer is D.